Yeah, good morning, everyone. I'm going to review Unit 1. Now, let me explain you only the important topics of Unit 1. I'm not going to waste much of your time. So, starting with block diagram of optical fiber communication system. Just I need to compare block diagram of communication system and block diagram of optical fiber communication system. See, a general communication system involves only three parameters. One is transmitter, another one is channel, another one is receiver. I repeat, a general block diagram of communication system involves only three components. One is transmitter, another one is channel, and another one is receiver. Now, to apply a signal to transmitter, we need a source. To receive a signal from the receiver, I need a destination. These are small things. The process that takes place at the transmitter is called modulation, and the process that takes place at the receiver is called as demodulation. These are general blocks of a communication system. Likewise, now I would like to say the block diagram of optical communication system. First, what I require is an information source. Okay, this source is used to transmit a signal to the transmitter, and the source will provide electrical signal. I repeat, information source will provide electrical signal to electrical transmitter. Okay, now I am talking about optical communication block diagram. What do you mean by optical energy? It is light energy. But what type of energy you are sending here from information source? Electrical energy. Now, there is a need to convert this electrical energy into optical energy. Hence, I will use a optical source. The example for optical source is either LED or laser. I once again repeat, information source transmits an electrical signal to a transmitter. Now the output of transmitter is what? It is an electrical signal. Now since I am talking about optical communication block diagram, now electrical signal should be converted into optical signal, and this is possible by adding an optical source. That optical source is nothing but a LED or a laser diode. Now this is coupled to a optical fiber cable. Now the output of optical source will be light energy, and that light will be passed through a optical fiber cable. The modulation that takes place here is called intensity modulation. I repeat, in order to send from transmitter to receiver over longer distances, modulation has to be done. Here the name of the modulation is intensity modulation. Now modulation has been done at the transmitter. Now the signal is coming towards the receiver. What is the process that has to occur at the receiver? That's nothing but demodulation or detection. Now your optical energy will be converted back into electrical energy. Now what is that you are using as a detector there? It might be a photodiode. Okay, Photodiode, what is the example for photodiode? Pin diode or avalanche photodiode. What are the optical detectors you are going to use here? You can either use pin diode or you can either use avalanche photodiode. Now, your optical signal is converted back into electrical signal at the receiver, which is received at the destination. I hope you understood this. Okay, Nama? Now, getting back to another block diagram. Now, this question he may ask you as fiber optical communication system block diagram. Now, the previous one which I have explained is analog communication system or general block diagram of optical fiber. Now, he will specifically say that explain the digital block diagram of a communication system. Digital means what you have to do at the transmitting side, you will encode. I repeat, at the transmitting side, you will encode the data. As you are sending the digital data, binary data, you will encode. Encode means you will apply some code and you will send. At the detector, what you will do? You will again demodulate. Demodulate in the sense you will decode there. Now let us see that. See here. Now your information source is digital in nature. Can you see it here? Your information source is digital in nature. What you are doing to the data, you are encoding at the transmitter. Then you have to use optical source. I said the optical source can be LED or laser diode. Okay. This is optical communication cable. This one is optical communication cable. You are coupling that optical source to what's so called optical fiber cable. Now, what you have to do at the receiving end, you have to do the demodulation. Demodulation is done through optical detectors. You can use pin photodiode or avalanche photodiode. Here he has used avalanche photodiode. Next, you have used amplifier and equalizer. What for we are using this amplifier and equalizer? So that we can reduce the noise and process the signal further. Now the encoded data will be decoded at the receiver and then you will receive the digital output at the destination. So this is pretty simple, ma. There is not much difference in both the diagrams. First I will say what is analog and then I will say what is digital block diagram. Once have a look at this, ma. See, either in analog block diagram or digital block diagram, information source should be present. In analog, you can just represent it with information source, whereas in digital, you have to represent it with digital information source. Okay, here you are using electrical transmitter. There you will say encoder. In digital form, you will say this as encoder. Here as optical source, you can use LED or laser. There also you can use LED or laser. Here you have coupled to optical fiber cable. There also you will couple to optical fiber cable only. Here you have written it as optical detector, which can be a pin diode or what you call it, avalanche photodiode. There also you can use pin diode or avalanche photodiode. Here it is electrical receiver. There you will say decoder. Instead of transmitter, you will say encoder. Instead of receiver, you will say there decoder. That decoder will decode the encoded data and forward it to destination. That's it. This is regarding block diagram of optical communication system. Now let us compare a general optical fiber communication system with conventional communication system. Conventional communication system means ordinary communication system or old communication system. Now see here. First point is regarding bandwidth of optical fiber communication system. It has a larger bandwidth. The bandwidth range is around 10 terahertz. 10 terahertz means 10 tera. Tera means 10 power 12. 10 power 12 into 10 is 10 power 13. Okay. The bandwidth ranges from 10 terahertz to 10 petahertz. Peta means 10 power 15. I repeat, 10 terahertz to 10 petahertz, PETA. Whereas a conventional communication system requires a bandwidth of around 500 megahertz only. You can see it here. Here this is 10 terahertz to 10 petahertz here, and this is 500 megahertz. Now optical fibers have less weight, whereas conventional cables will have more weight. I repeat, one of the advantages of optical fiber system is it has lightweight, whereas conventional communication system has heavier weights. Now this is immune to RF interference. So no interference takes place here. No means very, very less. Here you require external circuitry. Okay, you require external circuitry in conventional communication systems. Now, due to external circuitry in a conventional system, earthing problems will take place. Earthing problem means short circuit problems. Okay. Now, it's not such in the case of optical fiber communication system. It is electrically isolated. Isolated means separated. Hence, these are electrically separated. There is no chance of getting short circuited. Whereas in conventional communication system, okay, external circuit is placed inside the internal one. Okay, they are coupled. Hence, there is a chance of getting short circuited. Optical fiber communication system is electrically isolated, whereas conventional communication systems will exhibit some earthing problems. Now, talking about loss, for every 1 kilometer of cable, only 0.2 dB loss has been encountered using optical fiber cables. There is a loss of 0.2 dB for every kilometer, whereas there will be a loss of 10 dB for every kilometer in conventional communication systems. For example, if I use a coaxial cable, okay, if I consider a coaxial cable of length 10 kilometer, for 1 kilometer, if it is showing 10 dB, for 10 kilometers, how much it will show? It will show 100 dB loss. Whereas, if I consider 10 kilometer wire of optical communication, 10 into 0.2 is 2 dB. Now you can compare here. Here you are getting 2 dB loss for 10 kilometer wire of optical fiber. Here we are getting 100 dB loss, okay, for 10 kilometers. So which one is better? Obviously, your optical cable is better. Now, secured signal propagation. So in this communication system, there is security provided. Whereas in communication system, in conventional communication systems, the signal can be tapped easily. I hope this is very easy to understand. Okay, hence I am not repeating the topic now. And coming back to last point of optical communication system, the data rates are very, very high in the order of Gbps, gigabits per second, whereas conventional systems have lower data rates in the order of Mbps, megabits per second. Now, the same have been mentioned here again. Again, he's asking what are the advantages and disadvantages of optical fiber communication system. See, once again, I will repeat those points which I have studied. We have studied around 7 points now. First one, what we have studied, they operate at, they have high range of frequencies from 10 terahertz to say 10 petahertz. They are having less weight. Okay. Next, they are immune to RF interference. Next, they require high bandwidth. They require what you say higher data rates. They don't require external circuitry. These are what we say electrically isolated. And these have less loss while transmitting the data. Now, I would like to say some of the disadvantages of optical fibers also. So this will suffer from attenuation. Optical fiber will, you have clearly studied in the second unit about attenuation caused due to optical fibers. Attenuation is caused due to absorption, dispersion. Okay, we have studied material dispersion, we have studied intermodal dispersion, chromatic dispersion. Okay, all those things. One of the disadvantages of optical fiber communication is it suffers attenuation. It has complex electronic circuitry. And one of the important point is coupling of optical fibers is difficult. Next one is manpower. Skilled people should be there to connect it. So in order to reduce the noise, we have to on placing the repeaters at regular intervals between the cables. I repeat, to cover a longer distance at regular intervals of time, we need to place repeaters for every 10 kilometers or 20 kilometers. Okay, which is going to affect the cost of the entire system. Now, I'm comparing the optical communication system as well as microwave communication system. So we know that optical fibers are made up of either glass or plastic. But microwave systems are made up of either coaxial cables or waveguides. I repeat, optical fiber are made up of either glass or plastic, whereas microwave systems are made using coaxial cables or microwave waveguides for transmission of signals. Now, talking about its property, optical fiber are less in weight. We already studied it. But microwave systems have more weight because you are using coaxial cable. Now, we already studied here bandwidth. Bandwidth of optical communication is from 10 terahertz to 10 petahertz. And now this is bandwidth is lesser in range, that is from 100 megahertz to 10 gigahertz. 100 megahertz to 10 gigahertz, or you can say 100 mega. You can say 0.1 giga to 10 giga also. I repeat, this is from 0.1 giga to 10 giga. We already studied this. These are electrically isolated. Electrically isolated means electrically separated. But the microwave systems are affected by RF interference. This is not RE. This is RF interference, radio frequency interference. We have already spoke this point. For every kilometer, there is 0.2 dB loss. Here, for every 5 dB, there is a loss. Here, spacing should be large between the repeaters. Whereas in microwave systems, spacing between the repeaters should be very less. Now here there is a larger data rate in terms of gigabits per second or terabits per second. The data rates in microwave systems are in megabits per second. Right. Now security is more in optical fiber system, whereas in conventional means microwave system, signals can be tapped. Here there is no shielding at all in optical system, whereas shielding is required in microwave systems. Now talking about disadvantages, I'm comparing the disadvantages between optical system and microwave system. Optical system is expensive and microwave system is less expensive compared to that of optical system. Coupling becomes difficult. Coupling becomes difficult in optical system, whereas coupling is easy in microwave system. Now here power can be transmitted using LED or laser. There it is directly coupled to a transmission line. Now we cannot excite the terminal device directly here. Here we can connect it directly. Okay. Now the session is closing. Okay. Once again, all of you reconnect. Once again, all of you reconnect. I'm closing the session. Once again, everyone reconnect. Visista, stop recording and take a screenshot. Visista, are you able to hear me? Visista, are you able to hear me?
Yes, sir.